Hey, it's Tim the Tutor here with Free Test Prep Online, and in this video we are going to cover the synthesis and reactions of aryl diazonium salts. When we react a primary or an aryl amine with NaNO2 and HCl, the resulting product is a cation with a nitrogen-nitrogen triple bond. This is known as a diazonium salt. Diazonium salts made from primary amines are not particularly useful as they degrade into N2 very readily. However, aryl diazonium salts, that is, diazonium salts bonded to benzene rings, are useful synthetic intermediates, which we can do a lot of different things with. Let's explore the mechanism of the creation of a diazonium salt. In the first step of this mechanism, our NO2 from NaNO2 is going to react with HCl. We're going to grab the negative charge on the oxygen, and we're going to draw an arrow from it to the positively charged hydrogen on the HCl. Of course, that's going to kick off the chlorine as a leaving group. That's going to give us nitrous acid, which is still basic enough to react with another equivalent of HCl. So once again, we're going to take a lone pair from the oxygen and draw an arrow to the positive charge on the HCl. That's going to attach a second hydrogen onto that oxygen, which now makes it a good leaving group. So of course, in the next step, it is going to leave. That's going to give us something called a nitrosonium ion, NO+. The nitrogen on NO+ is an electrophile, so we can bring in a nucleophile, such as the lone pair found on our amine, to attack it. After this, we're going to get a series of proton transfers. Feel free to pause the video, as I'm not going to walk you through each proton transfer individually. After these 4 proton transfers, we're going to have an OH2 leaving group, so it's going to leave. And as it leaves, the lone pair remaining on that central nitrogen is going to form a triple bond between the 2 nitrogens. This will give us our diazonium salt. As mentioned previously, aryl diazonium salts are synthetically useful intermediates. That's because that N2+ group is a really good leaving group. We can use an aryl diazonium salt in 7 different reactions. The first one creates a phenol, something that you encounter frequently in organic chemistry, but isn't really straightforward to synthesize. To do this, we simply react the aryl diazonium salt with H2O. We can also use the aryl diazonium salt to add a nitrile group to a ring. To do this, we use CuCN. Ionic compounds that use copper are called Sandmeyer reactions, and there's several more that we can do. We can use CuCl, CuBr, and CuI to add chloride, bromide, or iodide to a ring. We can also use NaI or Ki to add that iodide. Adding a fluoride does not use CuF, rather it uses HbF4. Last, we can use H3PO2 to remove the N2+. The mechanisms for these reactions aren't typically something undergraduate organic chemistry students need to learn, so it's best to just memorize the reagents and what products they form. How to create an aryl diazonium salt and then substitute it with something else is a frequently tested question in many organic chemistry classes. So starting with a benzene, how would we create the aryl diazonium salt? The first step would be to carry out an EAS reaction, nitration. This is going to add a nitro group onto the ring. Now, once we have the nitro group on the ring, since it's a meta-director, we can then carry out an EAS reaction to add a different group to the meta position if we desired to. The next step is to convert that nitro group into an NH2. We can do that with H2PDC or any other reducing agent of nitro compounds. Now, since NH2 is an OP director, if we wanted to, we could carry out an EAS reaction after this step to add a group to the ortho or para positions. The NH2, of course, can be converted into the aryl diazonium salt using NaNO2 and HCl. Of course, once we add on that N2+ group, then we can carry out any of the substitution reactions of aryl diazonium salts after this step that we covered in the previous slide. Let's explore this a little bit more using the following synthesis problem. How would we add 3 chloro groups that are all meta to each other? This is a challenging problem because chlorines are OP directors. So we're going to use our synthesis sequence for an Aryl Diazonium salt to help us figure this out. So first, we're going to start with nitration. Since NO2 is a meta-director, you might be thinking that we can carry out 2 EAS chlorination reactions to add 2 chlorines to the beta positions to the NO2. However, that will not work because once we add on the first chlorine group, then we'll have an OP director on the ring. So what we're going to do instead is we're going to continue with our sequence of creating the Aryl Diazonium salt, and we're going to reduce that NO2 to an NH2. NH2 is a strong OP director. So what we can do now is we can actually carry out an EAS halogenation reaction with excess halogen, and we'll get a polyhalogenation. And we're going to add on 3 chloro groups when we do that. Now that those 3 chloro groups are added and they're all meta to each other, we simply need to figure out a way to get rid of that NH2. To do so, we can convert it into an Aryl Diazonium salt using NaNO2 and HCl, and then use H3PO2 to get our desired product. The last reaction we're going to explore is a coupling reaction of an Aryl Diazonium salt. You can see that if we react an Aryl Diazonium salt with another benzene ring that is substituted with a strong electron donating group, then we're going to get those benzene rings to be joined together via a nitrogen-nitrogen double bond. They'll be joined together at the para position to that electron donating group, unless of course that position was already occupied, in which case we will add it to the ortho position. That's because Z groups, or strong electron donating groups, are OP directors, which should lead you to the conclusion that this is probably just an EAS reaction that follows the EAS mechanism that we've learned previously. I'll show the mechanism below, but if you want a more thorough review of EAS reactions, please check out my EAS reactions video. If you got something out of this lecture, please feel free to like this video and subscribe to this channel. If you have any questions or comments, leave a message below. And last but not least, if you want more help or want easy access to valuable organic chemistry resources for free, be sure to check out the notes underneath this video with a link to join our community.